Everyone, Assalamualaikum warahmatullahi wabarakatuh to all of you. My name is Gita from Professional Affairs STEKOM, and I am a review of survey and analysis today. Today's session is recorded and broadcast live to all official. So for the to watch and listen, this recording is made available and ladies and gentlemen, today's speaker advancing engineering education through conventional coordination and sustainability reflects increasingly connected to world with this one. This becomes a lot of global inflation and challenges, many us essential in cooperation to lead within the of engineering education. And we are to have English guests today with a remarkable background and experience of sharing technical insight on the subject not only but relevant to academic institutions. Ladies and gentlemen, it is my pleasure to introduce our speaker, Mr. Marchenko. Mr. Marchenko.
I have some problem with audio. I couldn't understand what you mean, what your speech. Could you me printing or maybe I don't know how to decide this problem. Okay, so this call is okay. Can I start? Do you hear me? Is it okay? Is it okay? What is the communications? What is it? Okay. Can I start? Gita. Individual what? Wait a minute, sir. Thanks.
Hello.
Hello. Yes, I am here.
Is it audible, my friend?
Do you hear me well?
Can you hear my voice, sir?
What? Repeat after once more. Can I start? Yes.
Wait, Mr. Serhiy, I will welcome you first to our first speaking lecture. And Mr. Serhiy is who are respected academic and practitioner with strong expertise in electronic and engineering. His contribution in international academic collaboration and sustainable engineering education have made a significant impact across institutions and global networks. We are truly privileged to learn from your experience perspective today. Please join me. Welcome, Mr. Serhiy Marchenko. The floor is yours.
My name is Serhiy Marchenko. I'm head of Department of Electronics and Electronical Communications. I will introduce my department, the life of our students and our departments. As you know, electronics, electronical communications, and radio engineering, I'm on the most widespread modern ways of multi-service transport. Okay, sorry. The creation of modern broadband communications with surrounding world. The creation of modern broadband multi-service transport networks based on internet protocols. The development of subscriber access services and the implementation and optimization of internet telecommunication infrastructure, development of computers and mobile communication networks through mutual penetration on information, multimedia, and telecommunications. Other objects of professional activity of specialty electronics, electronic communications, and radio engineering. During the studies at the Department of Electronics and Electronic Communications, our students obtain in-depth knowledge of modern information and telecommunication technologies, electronic components and technical means of telecommunications. The second, acquire skills in programming microprocessor and microcontrollers like STM32, Raspberry Pi, and FPGA, Xilinx, using the programming languages assembler, VHDL, Verilog, C++.
Wait a
This
minute, sir. Do
what
you have any presentation that you need to
presentation?
share
Just
to
a
us?
second. Do you see my presentation?
Oh
It's the
no,
first.
no, unfortunately, we haven't seen anything in the screen yet.
What?
We don't have, we can't see the presentation yet right now.
Could you open my I'm sorry. I need some.
Or maybe you
How
can
can
help
I?
me by
How
sharing.
can I add my work space of the notebooks?
Or maybe you can share to us the presentation, and we will help you by
Okay.
sharing it in the screen.
Just a minute. I have sent my presentation PowerPoint. Could you edit this material, this presentation material in our chat? Could you share with other people, with other visitors?
Pardon? Or maybe you can share to us the material of the presentation via WhatsApp or no, not WhatsApp, I mean Zoom. We could help you to share it live on the Zoom.
Just a second, just a minute.
All right.
Tes. Hello? Wait a second. I believe there is some trouble in here with the audio. Hello, can you hear my voice clearly? You still unmute, sir. For right now, you still unmute, sir. Maybe you still mute your voice.
Yes.
Okay.
Sorry, yes. Can you hear me?
Yes, I can hear you clearly.
Yes. Okay. I'll try to share this presentation. Do you see this presentation? No, no.
No, we haven't seen it yet. Right now it's just your cam.
Yes, my cam. Could you help me to share this? Oh, okay. Unfortunately, I haven't submitted. I haven't noticed that. Okay, and now this document is sending to you.
All right. Send it via Zoom chat or email. Okay.
Just here.
Okay. Our admin will help you.
Thanks. Thanks a lot.
Is it visible in your screen, sir?
Yes.
Okay.
Yes, I see. I can see. Yes. Can I go on? Yes. Okay. I have stopped that our students during their studies at Department of Electronics and Electronical Communications obtain in-depth knowledge of modern information and telecommunication technologies, acquire skills in programming microprocessor and microcontrollers, and they master modern means of implementing telecommunication protocols using digital signal processing tools. And the last point, they master modern system of mathematical modeling and computer-aided design of radio engineering equipment, MATLAB, Simulink, Multisim, Elton Design, and Soft HFSS, and many others programming tools. Now I will briefly present the main laboratories of our department. It's a slide number 2, please. First laboratory of computer-aided design and modeling of radio electronic equipment, slide number 3. Yes, slide 3. The laboratory of computer-aided design and modeling radio electronic equipment. It's a modern educational and scientific space focused on the practical training of specialties and field of electronics and embedded systems. The laboratory is equipped with 10 modern computers, as well as the interactive boards and video sonic projector, which ensure effective visualization of educational materials and interactive teaching during classes. The material and technical base of this laboratory allow conducting practical and laboratory classes in the disciplines like computer embedded systems, microprocessors, electronics, software tools and electronics, programming of microprocessor systems, engineering calculations, mathematical modeling, and programming of debugging modules are performed at this workstation. Slide number 4, please. For in-depth study of the disciplines microcomputer embedded systems, 2 universal workstation equipped with Raspberry Pi formed microcomputers have been created in laboratory. They provide the formation of practical skills in working with embedded systems. They are programming in Python, as well as organizing data exchange with sensors and actuators. The use of Raspberry Pi allows students to master the configuration of remote access, reading digital and analog signals, slide number 5, creating graphical users interface and working with the video models. All of this creates conditions for the development of autonomous control and intelligence systems. Slide number 6. The next laboratory is Laboratory of Radio Receiving and Radio Transmitting Device. The next slide, please. This laboratory has equipment for conducting practical and laboratory classes in disciplines theory of radio engineering circuits, signal and process and radio engineering, digital signal processing, digital image processing, signal processing by FPGA, digital communication technologies, and radio technologies based on software-defined radio. Slide number 8, please. The laboratory includes 5 computerized workstations used for control and measuring equipment, calculations, mathematical modeling, and programming using modern software. 2 universal workstations equipped with the FPGA platforms, Spartan 6, Ritter 6, the Red PTIC system, and Raspberry Pi 5 enable students to implement digital algorithms, perform real-time signal and image processing, and develop prototypes of digital systems. The next slide. The laboratory also equipped with modern digital spectrum analyzers, analog device converters and digital analog converters modules, logic analyzers, oscilloscope, and signal generators allow detailed analysis of complex analog and digital signals, modulation methods, and signal generation under real operating conditions. Slide number 10 and 11 are devoted to develop practical engineering skills. Dedicated workstations are available for designing and assembling electronic and radio engineering devices, including PCB prototyping, soldering, and testing using modern FDM 3D printers and measuring instruments. In addition, SDR-based complexes, USRP-B. The next, please. Yes, thank you. SDR-based complexes, USRP-B210, Libra SDR, Airtel SDR with GNU radio software provide a complete cycle of experiments in digital communication systems, enable students to gain hands-on experience in building real telecommunication solutions. The next slide, number 11, it's Laboratory of Analog Electronic Devices. Slide number 13. The laboratory is equipped with all necessary facilities for conducting classes in disciplines, fundamentals of circuit engineering, power supply of communication systems, electrodynamics and radio wave propagations, antennas and microwave devices, and analog circuit engineering. The laboratory includes four computerized workstation for calculation and mathematical modeling using specialized software such as Microcap, Unsolved Electronic Desktop, Octave, SDR Sharp, Fusion 360, and Cura. Slides 14 and 15 are devoted to universal workstations, are designed for study of analog devices and equipment with the modern multi-channel digital oscilloscopes, signal synthesizers, power supplies, and analog signal generators. Experimental benches with operational amplifier, breadboards, and components bases allow students to design and investigate prototypes of analog electronic devices. Slide. Its slide describes the special workstation for study of operational amplifier. We can see the digital oscilloscope and the up-to-date digital synthesizers for forming the necessary signals. Slides 16 and 17, it's a dedicated, yes, thanks. A dedicated workstation for antenna technology and high-frequency devices. Is equipped with high-frequency oscilloscope, vector network analyzer like Nano VNA FV3 or Libra VNA, spectrum analyzers, and experimental antenna samples. The equipment enables research on radio signal generations, reception, amplification, and matching antenna feeder system. Slide 18 and 19 depict. The laboratory also includes a prototyping workstation with soldering equipment and measuring instruments, allow students to assemble, tune, and test developed devices. In addition, a student research complex electronical telecommunication systems operates in this laboratory, focusing on radio wave propagation, modulation, and long-distance communication, including satellite and ionospheric systems. Overall, this laboratory provides both educational training and scientific research in field of electronics and telecommunications. The next slide, it's a workstation for research to telecommunications in the ultra high-fi frequency and the very high-fi frequency. We used the digital modern transceivers. You can see near the monitor, and we can program in a way to communicate with any radio fans who has the very high-fi communications. Okay, slide number 21. Digital Devices Laboratory. In this laboratory, students study microcontrollers, digital devices, and information security technologies. The training begins with the learning modern electronic components and digital logical elements, which form the basis for Boolean algebra implementation, signal processing, and control systems. This enables students to model digital systems and later implement them in real hardware. Slide 23. To better understand operating principles, students emulate microprocessors' operation and then move on practical work with the microcontrollers. Also, students gain theoretical and practical knowledge of microcontroller architectures and operating principles of leading manufacturers, studying structure sets, and learn the fundamentals of programming. They design, program, and debug embedded system based on platforms such as Arduino STM32 and ESP32. Connect sensors and actuators, config communications interface UART, I2C, SPI, and use pulse width modulations. The next slides 24, 25 that depicts the main type of laboratory work include programming embedded systems in C++, working with peripherals, developing Internet of Things and robotic projects, and performing diagnostic and debugging of electronic sockets using oscilloscopes and logic analyzers. The acquired knowledge, don't go. The acquired knowledge and skills prepare students for professional careers in field of embedded systems. Okay, let's consider the scientific work at our department. The next slide number 26. Yes, two main directions are developed at our department. The first the directions is the development of methods for calculating applied electromagnetic problems for analysis of microwave devices and antennas. And the second is the development of efficient methods automated control of asynchronic electrical drives using modern electronic means, advanced components, and high-performance IRM microcontrollers. Within applied electromagnetics, under the supervision of Associate Professor Morozov Valentin Mikhailovich. There are several methods based on integral equation method have been developed and applied, including the method of integral equation of intersection subdomains, the penetrable region integral equation method, and the alternating Schwarz method. These approaches enable effective solution of three-dimensional vector electromagnetic parameters, where classical electromagnetic problems for structure with complex geometry and inhomogeneous material parameters, where classical methods are limited, unfortunately. Slide 27. The penetrable region integral equations method is used to analyze electromagnetic fields in waveguide and antenna waveguide structure with dielectrical and magnetodielectrical materials. It has been applied to calculate characteristics of waveguide phased antenna array, as is the influence of material inserts on field distribution, and evaluate radiation and matching properties of microwave antenna systems. Slide 28. The method of integral equations of intersections subdomains was developed to study electromagnetic wave diffraction in waveguides with complex geometry inhomogeneities, includes step transitions, junctions of waveguides of different shapes and sizes, and dielectrical inserts. The alternating Schwarz method was applied to ensure convergence of numerical solutions for three-dimensional vector diffraction problems, particularly in cases where conventional iterative schemes are unstable. It has proven effective for analyzing waveguide transitions, composite waveguide system, and antenna waveguide structures. Okay, slide 29. Under the supervision of Professor Syanov Alexander Mikhailovich, at our departments develops methodologically grounded approaches to controlling asynchronous electrical drives with the integration of automation system and modern electronic components, including STM32 microcontrollers. In particular, discrete phase control methods are implemented, combining the advantages of vector control with simpler realization, ensuring continuous phase advance and optimal ratio between converter output voltage and rotor speed, which improves drive accuracy and dynamic. Slide 30. 30, please. Yes. This research direction, energy recuperation system with discrete phase control are being developed, integrating voltage stabilization and grid phase tracking without additional rectifiers or autonomous inverters, thereby increasing energy efficiency and enable real-time parameters regulations. Well, overall, our department, the educational and research infrastructure of our department integrates fundamental theory with practical engineering, providing students with strong professional competitions in electronic, telecommunications, and embedded systems, and forming a solid foundation for training highly qualified specialists capable of addressing complex engineering challenges. Thanks for attention. Okay. Uh, how do you see international collaboration shaping the future engineering education, especially for developing countries? In very interesting questions. Sorry, something happened with camera. You see, I think in our modern life, in free world, I think it may be the strong side of international cooperation, international collaboration, because each of us has own point of view, and when we communicate with each other, we can construct, we can make a very interesting, very complex structure. I mean not only structure, but the questions. If we have some scientific problem in international collaborations, I think it's the most important and effective way to find the decision, because each university, each country has own point of view of this problem, and combining this point of view, we can have the efficient way. What are the biggest challenges you have faced in establishing international academic collaboration, and how did you overcome them? You see, unfortunately, Ukraine in a war, and now main part of university staff and main part of the students can't go abroad, and that's why we try to keep in touch with our colleagues with the foreign university only online. I think in future we will have a huge wish to take part in a real life, because we collect some knowledge, some skills during these years, and we are glad to share this information, because as you know, many Ukrainian military company have developed up to date the electronical devices connecting with the radio canceling the FPV drones. It's wrong using of the words canceling, but now modern war, it's a very modern war, and needs new knowledge, new science in the electronics and telecommunications. For example, we are connected with our warriors, and sometimes we assist and advise them to decide some technical problems. And I think this experience with these collaborations with our warriors, our military troops, we can share for country who has have modern army. How can university motivate engineering students to actively participate in global projects or exchange programs? Motivate. I think in Ukrainian university maybe are the easiest. Why? Because our students haven't had any possibility to go abroad, and after ending this war, I think the majority of guys will have a huge wishes to go abroad. To share their experience, to gain some knowledge in some aspects of science that we can't find now. We understand what we lack in the science and the teaching process. We collect these problems. We understand, we realize that we lack of the experience, collaborations, and with the foreign universities. Okay.
All right. Thank you very much, Mr.
Thank you.
Yes. I think that's the last question that has been sent with the long participants. Thank you very much, Mr. Serhiy, for the insightful and inspiring presentation. And if there are any question more from the audience, please just include your name, institution, and your question, and we can read them clearly. And Mr. Serhiy will answer you directly. Mr. Serhiy, you mentioned about the Ukraine. Yes, I have questions personally from myself, so that you could share your perspective with this question. How has the current situation in Ukraine influenced the development of engineering education, and what adaptation have universities made to maintain high quality learning? Maybe you could answer from your perspective or your university, and we could learn by it.
Oh, I'm sorry, Gita. Could you explain in more clear way?
Oh yes. How has the current situation in Ukraine influenced the development of engineering education, and what adaptations have universities made to maintain high quality learning? So it's lined with our theme today, with advancing engineering education through international collaboration and sustainability. Yes, I want to know about your
Okay, I see.
perspective. Yes.
I see. First of all, I want to say that our government and our presidents will see future students, future young people is well-educated person. 2 years ago, the government provide the in-depth studying and learning English in Ukrainian schools. I think it's maybe the ground step for international communications. And the second, our students understand that they need more knowledges to get a good job in future, and maybe future job in the military companies, because the destiny of Ukraine seems to me like in Israel, who is surrounded around the Arabic country who are enemy. And our students, wants or don't want, they will have to study very hard to get good knowledges, because their future are connected with Ukraine. In our countries, they have the neighbors like a huge country, Russia. Russia is our enemy, maybe for 400 or 300, and all of this time, and we in the war with it, and I think it may be the first motivation steps for our students, for our youth, to gain good knowledges in the engineering, because engineering, as I know, it's a branch of industry of the economics. They gives the most amount of money in the product, because the technology is the richest part of any product, and many other aspects. I maybe now I missed some of them, but during studying with my students, and I every day repeat that you need knowledge, because this war is gradually becoming more technologically. There are many robots, automated ground robots. They take part in the war. But by the way, do you know the unmanned grounded the car take part in the war, and this systems is very complexity. The engineers, the projects of creating this system needs electrical engineering, computer programming engineering, electronicals, and radio engineering. And as we know, the war, it's a kind of human life when the technologies change very fast. And who has information, who has new methods to create some technological equipment, who will be the who will have a victory, like this.
Okay, thank you very much, Mr. Serhiy,
You're
for
welcome.
your answering all of the questions and your valuable knowledge you shared with us today. As we come to the end, before we end our session, we would like to have a photo together. And all of the participants, we would like to you open all of your camera and take a picture together. Yeah, online.
I'm sorry.
Okay. Thank
Thank
you.
you.
Okay. Our moderator will help you. Will help us today. I count to 1, 2, 3. And 1, 2, 3. Different pose. 1, 2, 3. Okay, thank you very much, Mr. Serhiy, for all of your presentation. Ladies and gentlemen, now we have reached to the end of our International Visiting Lecture, Day 2. On behalf of the committee, we would like to express our deepest gratitude to Mr. Serhiy Marchenko for his enlightening presentation, and all lecturers, staff, and participants who have joined us today, and everyone who has supported this event. Your participation made this session meaningful and impactful. I am Zalfa Gita Salsabila, I am MC for today, signing off. See you in your upcoming international program. Good afternoon and have a wonderful day.
Слава Україні!